Now we are into chapter 10, which is an introduction to Redux. Redux is a library that helps us manage the state of our application. It is typically used in medium to large applications with complex data flow. So the benefits of Redux is that although it's often linked to React for management of application state in React applications, it is a standalone library, and it also makes it easier for unit testing our application because Redux is heavily based on functional programming. For example, in the below code, we can unit test our adding and removing function that take in an existing state and returns a new state, as you can see here. Redux also makes it easier to implement undo and redo since all the updates to state are captured. So transiting from component states to application states is a general principle. We should start simple and use local component state first, as introduced in this book. And then when our app is growing, then we can refactor components to use Redux to manage application states in a predictable way. For example, in a Facebook application, we might have the following local component state as the initial state, right? We have our app component state here, and it has these messages here. And then Redux will make it easier for us to view our application state by having us store all the data in a single location called the store. You can think of the store as a single JavaScript object that acts as a local client-side database. From the single store, we manage the state of the current logged-in user, messenger tabs open, post, etc. For example, as you can see here, this is an example of a store, and when we are understanding the Redux flow in our React app, there are components which want to manipulate the app state. The first building block of Redux are actions, which are dispatched by components. Actions are simple data structures with no logic that describe what to change. They contain a type string property which describes the kind of action, something like add ingredient or remove ingredient. Actions can also contain a payload which contains the actual data for performing of the actions. You can see here we have a payload, and we also have reducers, and the thing that changes the store is the reducer. The reducer will check the type of the action and execute the logic for that kind of action, and finally update parts of the state. So with our store subscriptions, we use a subscription model. The store triggers all subscriptions whenever the state changes. Our components can subscribe to the updates and receive them automatically. We will see a sample implementing of actions, reducers, and store subscriptions in the next few sections. So in our VS Code, we'll create a new file called persons.html, as you can see I have already. And in our persons.html, we're going to define our actions. As mentioned, the actions are the only way to communicate with our store inside the script tag. The script tag is at the bottom here. This is a script tag. And then our two functions, add person and remove person, each return an action object. Here you see the action object consisting of a type property which describes the kind of action we are performing. In our case, we have two actions, type add and type remove. It's up to us whether we want to, well, what description we want to give it, right? Other than type, we have the other, which we call the payload value of the action. In add person, our payload is ID, name, and age, as you can see there. And then in remove person, our payload is just ID. And add person has a person data object, which in turn contains several properties as its payload, since we need these properties to describe the person we are adding. So remove person, however, only requires ID as a payload, which we only need an ID to know which person to delete. So with our reducers, actions specify what is to be done, how it is to be done, and left to the reducer. The reducer acts as an intermediary between the store and actions. To illustrate this, we have the following code below here, right, which creates the initial state, and yeah, we have this function reducer here, right? And then with this, we will initialize our state to initial state and empty persons array, and if state is undefined to begin with, then the rest of the code is a series of if-else statements while we handle our actions. The reducer method gets the action object, which gives the reducer access to action type and payload. So we have to create a copy of the existing state and then replace the existing persons array in it. The state.persons.concat method returns a new array that contains the old values along with the added new person. So when the action type is removed, will return a new array with a specified person removed using the filter method. So if we want to connect our actions, reducer, and store, we'll create our store and tie our reducer function to it by adding the code below here. We create this variable called store, and that's going to be redux.createStoreReducer, right? And then after that, we are going to create a new store with redux.createStore and provide our reducer as an argument. With this, we have linked our actions, reducers, and store together. To see how it all works together, we call the dispatch method of the store object and provide it with an action as an argument, and we add the following code right here. And then to see the store states, each time the application state is modified, we add the following code here. And this is what it's going to look like in our browser. As you can see, we have these objects here, each of which have an ID, a name, and an age. So that was it for chapter 10. This was Lucky, I was the driver, and Asanda was my navigator. Thank you.